Hello friends, today we are going to start the actual syllabus of semiconductor device, which is a topic of physics 2. In the first lecture we discussed the important concept which will be required to study this chapter. So now I am going to start the important subtopic of that chapter, semiconductor and devices, is PN junction diode as a rectifier. Now before starting this rectifier, actually what is the need of rectifier, that we are going to understand. Why rectifiers are required in electronic circuits. Basically, many electronic gadgets like charger or any portable devices, they require DC voltage. Okay, they require what? DC voltage. Now, one important question that might be arise in your mind. What is meant by DC? DC means direct current, and AC means alternating current. So, the current which does not change its direction for all time, that current is called as DC current or direct current, and the current which continuously changes its direction, that current is called as AC current. Now, why this AC is not required for such devices, and why that DC is required? That is the important question. For some processes like charging, then you know the important process of electrolysis, electroplating, for all that purpose you require direct current. So in your house available current is AC current, means in our domestic appliances we always use AC current or AC voltage, that is 230 volt. So to carry out such kind of activities we are using what? DC. So how to generate DC voltage from AC voltage? This is an important question. So answer for this question is given by this particular circuit, that is rectifier. So rectifier means it does rectification process. So the rectification is a process in which AC voltage is converted into pulsating DC voltage. So this pulsating DC means what? We will discuss it in great detail, but for time being, you remember conversion of AC voltage into pulsating DC voltage. This process is called as rectification, and the device which performs the process of rectification is called as rectifier. So rectification and rectifier, the conversion of AC into DC is called as rectification, and the device which performs this process is called as, or the electronic device which performs this process is called as rectifier. This is the important point. Now, if you observe this block diagram, actually this is a block diagram of regulated power supply. Now what is meant by regulated? Rectifier, it is a sub part of the regulated power supply. In this block diagram, if you observe, it is one of the block of the regulated power supply. So regulated power supply consists of different blocks, like first is transformer, then rectifier, then filter and voltage regulator. We are now discussing the one of the block, diode rectifier, in this particular lecture. So this particular rectifier is classified into two categories, that is half wave rectifier and full wave rectifier. Now what is meant by half wave? What is meant by full wave rectifier? Suppose this AC voltage is given to the rectifier, and only half a part or half cycle of this AC voltage is converted into DC voltage, or the half cycle of the AC input voltage is being rectified, and remaining negative half cycle is not rectified. It means actually what happens? That particular rectifier utilizes only half of the input and converted into DC voltage. Remaining input it does not take into account. That's why that particular rectifier is called as what? Half wave. Half means it relates with which part of the or which portion of the input that rectifier will respond or that rectifier will utilize and convert into DC. That's why this is called as half wave rectifier. There is another type, it is full wave rectifier. Full wave. Full wave means what? That rectifier is utilizing both the cycles of AC input voltage. It also utilizes the positive half cycle, also it utilizes the negative half cycle. Both the cycles are rectified in case of full wave rectifier. That's why this is called as what? Full wave rectifier. Now, if you want to understand this half wave rectifier and full wave rectifier, you can understand with a simple example. Whenever we are, suppose we demand, suppose we are in summer season, if we want to drink some cold drink, then what will happen? Or sugarcane juice, that time what will happen? We demand for half glass. It means what? We pay for only half glass. The glass, complete glass is in front of us, but we utilizes only half of it. That's why we pay for only half of the amount. It is half wave. Means what? In that case, we only utilizes the half portion of the glass for our convenience. That's why this is called as half. So in that context, this is correlative, half wave and full wave. Which part of input is converted? This is called half wave and full wave rectifier. Okay. So up till now we have discussed rectifier, its types, rectification, definition of rectification and definition of rectifier and need of rectifier. Now we are discussing half wave rectifier. In this half wave rectifier, from exam point of view, you have to prepare the circuit diagram, then its working and its waveform. So circuit diagram of half wave rectifier consists of what? This is actually application of diode. In the previous lecture I already told you, this is diode can be utilized as a switch. So this is the application of diode as a switch. So in half wave rectifier circuit diagram, it consists of a AC input voltage which is to be converted into DC, then which is applied to this single phase transformer. So what is the function of transformer? Transformer will convert one AC voltage into another AC voltage, but with decrease in strength or increase in strength. Whenever transformer convert 230 volt into 1000 volt, that time that is step up transformer. And if transformer is converting 230 volt into 12 volt, that time it is a step down transformer. So transformer converts only AC to AC, but with of different magnitude. It means it is converting AC voltage into AC voltage. That's why the name of this particular block, that particular device is transformer. It is not converting actually, it is transforming. It means it is only changing its strength. Nature is unaltered. It means nature is not changing, AC only. Converter means it is nature is changing. That's why this rectifier is also called as AC to DC converter, because it is changing nature, AC to DC. But transformer is what? It is converting AC to AC, but with of different magnitude. That's why this is called as transformer. So what is the necessity of transformer? Because this diode has to operate, otherwise the diode will burn out. So that's why it is converted into low voltage of 12 volt. Then what happens? In this diode acts as a switch in this circuit. What is the function of this diode in this circuit? It acts as a switch. Whenever it is closed switch, it provides a path for the current. Whenever it is open switch, it becomes open switch. No current will flow, because in current through open circuit is 0. And this is a load across which we are interested to measure output. So across this load resistance, we measure the output voltage. So this is a diagrammatic representation of rectifier, half wave rectifier. So important observations in half wave rectifier, only one diode is required. This is the important point. Okay. Second important point now, working. How it works. Whenever I am applying this AC sine wave, this particular AC voltage into this transformer, so this AC is continuously changing. So during the positive half cycle of AC input voltage, what happens? This diode is forward bias, because I already told you when diode is forward bias. Whenever the anode side is more positive than cathode, then diode is forward bias. So that during this half cycle, the diode becomes forward bias and it acts as a closed switch. So since it acts as a closed switch, so that what happens? The current will take path from CEF and it flows through this load resistance RL. And you are getting the output voltage for this particular half cycle as shown in the figure, which is the output voltage. So from 0 to T/2 period, we are getting the output voltage. Now, since input is changing continuously, once the first half cycle is over, during the next half cycle, now what happens? Now, during the negative half cycle, the anode voltage is less than now cathode. Now anode voltage becomes lesser and lesser as compared to cathode. So diode becomes reverse bias. And as you know, as the diode is reverse bias, it acts as open circuit. So whenever diode acts as an open circuit, means this diode becomes open. So the path is broken down in this circuit. So current, there is no path for the flow of current, and current through open circuit is 0. So current flowing through this load is now 0. So you are not getting any output voltage in the diagram, because output voltage is equal to I into RL. Current is 0, so output voltage is 0. So during negative half cycle, the output voltage is 0. So as per the definition, during positive half cycle of AC input, you are getting the output voltage. During negative half cycle of AC input, you are not getting the output voltage. That's why this is the half wave rectifier. In this manner, it converts this AC input voltage into pulsating DC, and in which only one half cycle is rectified and another half cycle is not rectified. So you have to write, during positive half cycle, diode D1 is forward bias. It acts as closed switch. So current takes path from CEF and the voltage is obtained across load resistance. During negative half cycle of AC input, diode D1 is reverse bias. It acts as open switch and no current flows through D1. So output voltage is 0. So from this half wave rectifier point of view, you have to focus circuit diagram, working and waveforms. So this is a important point, and this is all about half wave rectifier. After discussing the half wave rectifier, now we are going to discuss its advanced version, that is full wave rectifier. So as per the discussion of half wave rectifier, we know that in half wave rectifier only the half input cycle is rectified. So we are getting the output for only one half cycle. And what happens, what is the actually important drawback, or what is the important flaw in that half wave rectification? One half cycle is wasted because we are not utilizing that particular half cycle of input at all. We are not utilizing this half cycle. So for that purpose, there is some modification has been done in case of half wave rectifier. What modification done? That we will discuss in terms of circuit diagram, and the name is given full wave rectifier. Full wave rectifier. So if you observe the circuit diagram of full wave rectifier and compare it with the previously discussed half wave rectifier circuit diagram, then it has been observed that there is a one addition of the diode in the circuit of full wave rectifier. One diode is added in the circuit diagram of full wave rectifier. So it consists of two diodes now, D1 and D2. And another important point, the secondary winding of transformer, this is the primary winding of transformer, this is the secondary winding of transformer. Secondary winding of transformer is center tapped. Center tapped means we can do the arrangement of this that center tap transformer, so that there is a splitting of phase take place. Phase means polarity will be reversed automatically once the cycle is reverse. So this arrangement is called as phase splitting or phase splitter. So this is done by the center tap transformer, and the secondary winding of transformer is tapped, and the load is connected on the output side. Now how it works? During the positive half cycle of AC input voltage, this diode D1 is forward bias. Diode D1 is forward bias because anode is more positive than cathode. But diode D2 is reverse bias. So diode D2 acts as open switch and diode D1 is closed switch. So since diode D1 acts as closed switch, then the current will take path from C, E, H, R and Kg. C, E, H, R, L, Kg, because this diode is now open. So this is a path for the flow of current in forward bias. Okay, so once this first half cycle is completed, then we are getting the output for that particular cycle as per the half wave rectification. Now what happens, due to the phase splitting, this is positive and negative. Now what happens, there is a reversal of polarity. So this point becomes negative and this point becomes positive. Now this diode D1 is now reverse bias. So diode D1 is reverse bias, it acts as open switch, and diode D2 is now forward bias because this point is positive. So anode is positive, cathode is negative. So now this is a closed switch. So current now take path from where to where? Current flows from here to here, that is from D to E, then from H to K and then G. It means now what happens? Current will flow from anode to cathode. The path of the current or the path which followed by the current during both half cycle is the same, but they have taken it through the different diodes. So when we add one diode in the circuit of half wave rectifier, that time what happens? This second diode is utilized for the rectification of second half cycle, that is negative half cycle, which is not possible in half wave rectifier. So we are getting the waveform like this. This half cycle is rectified, we are getting the output voltage. Second time we are getting the output voltage for negative half cycle, this. Then for again second cycle starts, in which first half cycle we are getting the output is this, and in second half negative half cycle this. So both the half cycles are rectified and we are getting the output in such manner. So what is the observation from this? In the rectification process, whatever output we are getting, that output current is unidirectional. This is an important word, unidirectional. Why unidirectional? If you observe here, input is positive, okay, output is also positive. Then next means in negative half cycle, what is happening? This is a negative half cycle, but you are getting the output only positive. It means you are converting your input into unidirectional output. So this is also one of the important property of rectifier. So this is a circuit diagram, working and waveforms of full wave rectifier. Now we are going to discuss what are the drawbacks and advantages of both the rectifier circuits. If you consider half wave rectifier, it is easy to remember all the drawbacks and advantages, and in working itself indicates. In half wave rectifier what happens? We are only utilizing half cycle. That's negative half cycle is wasted. That's time we are not fully utilizing the input. So there is a rectification takes place only during one half cycle. So this is a drawback of half wave rectifier. Second important is what? The second drawback is related with first only. If we are utilizing something is utilizing, or someone is utilizing full things, it means it is more efficient. Now we are utilizing only one half cycle. Something is waste, it means what? Efficiency is less. And this is which process? Rectification. So rectification efficiency is less in case of half wave rectifier. This is an important point. And third important point is what? Ripple is more. Now this is an important point. What is a ripple actually? You know that suppose if this is a AC waveform, then ideally DC means like this. But if you observe, we are not getting such kind of waveform in case of rectifier. We are getting this kind of waveform. Now in this waveform also some AC is present because it is changing. So whatever AC content is present in the output of rectifier, that particular content of AC is called as ripple, and that particular output is called as pulsating output. That's why in the definition I already told you in rectifier, what is the definition of rectification? It converts your AC into pulsating DC. It is not pure DC. It consists of some content, AC content is still present in the output of rectifier. So that ripple is undesirable for us, because we are actually, our task is to convert pure DC. we don't want any AC, but still AC is present. So that content of AC is more in case of half wave rectifier. If you go for full wave rectifier, it becomes lesser. So these are the drawbacks of half wave rectifier. Now full wave rectifier advantages are whatever drawbacks of half wave rectifier that are overcome in full wave rectifier. What are the first drawback? The rectification takes place in only one half cycle in half wave. In full wave, rectification takes place in both the half cycles. So if rectification takes place in both the half cycles, so if rectification efficiency is more because both the half cycles are utilized. And third, ripple factor or ripple is less in case of full wave rectifier. Now this ripple means actually what? Ripple means, I already discussed, it is the presence of AC in the output of rectifier. That ripple is called as ripple content, and actually it is indicated by one factor called as ripple factor. Now we will discuss this ripple factor in very great detail manner in very short time, so don't worry about it. Just for time being, you remember ripple content is more in case of half wave rectifier and ripple content is less in case of full wave rectifier. So these are the all advantages of full wave rectification. Now we are going to discuss important term, that is ripple factor. As we have initiated the discussion of ripple in the discussion of full wave rectifier drawbacks and advantages. Now we know that this ripple actually means what? The output of rectifier is a unidirectional DC ideally, but practically we get pulsating DC. It means it contains some part of AC in that output. So the ripple means actually the small fraction of AC component present along with DC in the output of rectifier is called as ripple. This is important. Second important point is what? The smaller the ripple, then what happens? When the ripple is smaller, then rectifier is more effective. This is also important point. As ripple content is less, then effectiveness of rectification is more. It means if ripple content in the output of rectifier is less, so rectifier is more effective. So as ripple increases, rectifier becomes less effective. This is the important point. Then there is one important formula of ripple factor. As you know, this formula, how this formula can be remembered, you know that it is a comparison of what? It is a comparison of AC content with actual DC content, with DC present. Means our requirement is DC. How much AC is present or over what base? DC. Like we write 1/5. So we can compare. Likewise, how much amount of AC is present in the output of rectifier in that particular DC. So this is a formula for ripple factor, RMS value of AC component upon value of DC component. This is called as ripple factor. Okay. Now, important point, this particular diagram indicates or shows the ripple content. This is actually a horizontal line, it indicates our regulated output, and over that particular regulated output there is a sinusoidally varying signal, or it is a voltage waveform. This is a ripple content. Actually it is undesirable, it is not required. Actually this output should be settled at this line only, but it is varying below and above that line. So the whatever voltage, this peak to peak voltage, it is called as ripple voltage. It means that voltage varies from one peak to another peak. So this is called as ripple voltage. We have to avoid this ripple, we have to eliminate this ripple. So what is the method, how to eliminate that ripple content in the output? So there are different circuits. This is called as filter. So filter, which is an important part of the regulated power supply, as already I have told you, this is a regulated power supply in which diode rectifier has already discussed, and next part is filter. So this filter is connected at the output of rectifier. So what is the function of filter? For filter removes the ripple from the output of rectifier and it only allows DC component. In this way we can eliminate the ripple content. So this is a basic diagram of rectifier along with filter. The output of rectifier is connected to filter, and how to construct a filter. So to construct a filter, you can utilize the capacitor. How the capacitor can be utilized? Because listen here, this is a load and this is a capacitor. This capacitor is connected at the output of rectifier, and this ripple content or the pulsating DC is connected to the capacitor. As that particular voltage is pulsating, it means it also some amount of AC is still present. So that magnitude of AC changes, that time what will happen? Listen here, suppose this is a point and this is increasing. At this particular point, these capacitor charges to peak point. Now whenever this capacitor charges to peak point, now the voltage across capacitor remains constant. And now what happens? Now this capacitor starts discharging, and when it discharges, capacitor always discharges through the load. If there is no load across this capacitor, then this capacitor will act as a battery of particular voltage. Now since this load is connected, now this capacitor will deliver the current to that load, and due to which now what happens? It starts discharging, and again when it discharges up to point B, again next particular cycle will start, and it reaches to again point C, which is the peak value. Again it charges. Again next point, next time what happens? It discharges. Again charges, discharges. So what it does? Capacitor charges, discharges. It means what? We require the output which is unregulated. It means we require this. We don't require this kind of nature. We are actually coming closer to this nature with the help of this making use of capacitor. So that's why this particular discharging time constant is what? It is more. It is taking more time. That's why the value of the capacitor which is used in this particular filter is very, very large. There is 1000 microfarad, 860 microfarad. Why? Because the discharging time constant is given by R into C. So as this C increases, time constant increases because load is fixed. So that's why we can use this C filter, capacitor filter. In this way, capacitor can be utilized for the removal of ripple, and this is the application of that capacitor as a filter. So basic important point, filter is used to remove the ripple content in the output of the rectifier with the help of capacitor. Now regulated power supply and unregulated power supply. Suppose this is a load. If I am changing the load, suppose this particular circuit is designed for 5 volt power supply, this particular power supply is designed, and if the output is if I am changing the load and my output is also changes, if I have changed the load, that time it is unregulated power supply. So if the output of the power supply remains constant despite of change in load, then this is called as regulated power supply. And if output of particular power supply changes with change in load, it is unregulated power supply. So there should not be any change in the output even though you are changing the load. So these are all important facts about this regulated power supply. So after discussing one by one, this is a complete block diagram of regulated power supply, in which first is transformer, which converts your AC 230 volt into low voltage AC, then rectifier that we have discussed, it converts into unidirectional or pulsating DC, then that pulsating DC contain ripple, which is removed by this filter, which is capacitor filter, and output of the filter is given to voltage regulator, that we will be discussing in next lecture. Actually, what is this voltage regulator? And finally this is load. So all these particular are the blocks of regulated power supply. So in this manner, in this lecture, we completed important application of diode, that is diode as an rectifier, then what is meant by ripple, and finally we have discussed the filter circuits and what are its application. Thank you.